Welcome. In today's problem, we discuss a previous gate problem 2022 for 1 mark. Okay. The question is here. The magnetic bearing of the sun at a place at noon is south 2 degree east. The magnetic declination at that place. So if you take meridians, take meridian, it is north, this is south, and this is east and west direction. Okay. And is saying southeast. So this is bearing angle or magnetic bearing, that is 2 degrees. From south to east, that is anti-clockwise direction. He was asking to find the magnetic declination is at the place. So generally we have formula true bearing is equal to magnetic bearing plus or minus magnetic declination. Okay. Similarly, if you want magnetic declination, the magnetic declination is equal to true bearing. It may be minus magnetic bearing or true bearing plus magnetic bearing. Okay, right? So this is the formula. And now you want magnetic meridian. So now you come back to the figure. This is my figure here. Okay, the figure says that so south 2 degree east. So it's very simple. So convert this south 2 degree east into double whole circle bearing system. So it is 178 degrees. Okay, this is 178 degrees. That is magnetic bearing. So geomatic bearing is 178 degrees. Now I want true bearing. So I want true bearing is, now true bearing is nothing but it is 180 degree. Why? Because at sun at a place at noon, at afternoon, if take afternoon, the angle is either 0 or it may be 180 degrees. So true bearing or geographical bearing will be exactly 0 or 180. So we'll take as 180 degree at noon. So 180 and here 178 degrees. So now I want to find magnetic bearing. So magnetic bearing is equal to true bearing minus magnetic bearing. So I want magnetic meridian. Sorry, I want magnetic declination. Declination is true bearing minus magnetic bearing or true bearing plus magnetic bearing. So I'll go with the first case, that is magnetic declination is equal to true bearing is 180 degrees minus magnetic bearing is 178 degrees. Actually, the answer is 2 degrees is different. 2 degree east. Okay. So 2 degree east is my answer for this question. Okay. The answer is 2 degree east. So here position indicates east direction. So magnetic declination is 2 degrees east. So it is MD. True bearing plus or minus magnetic declination. So plus stands for east. Plus indicate east. Okay, and correction is negative. So it is positive east. So I'm applying negative sign here. West negative, and correction is positive. So here is saying south 2 degree east. So east is positive, correction is negative. So 180 minus 178 degree, then the answer is 2 degree east. Okay, this is my answer for this problem. Thank you. There is one more previous gate question for 1 mark, that is 2022. The question is very easy. The error in measuring a radius R is given 5 centimeter. Circular rod was 0.2 percentage. So here percentage of error is 0.2% for 5 centimeter circular rod. The cross-sectional area of the rod was calculated using this measurement. Then the resulting absolute percentage error in the computed area is, so round off to 2 decimals. So we have formula here. So given radius of circular rod is 5 centimeters was 2%. So error of measuring was 2%. And right here error in rod is 2%. 0.2 into by 100 into 5. So this is 0.01 centimeter. Now we have area formula, circular rod area pi r square. So the formula is pi r square, and error in area also is there. So this is 2 pi r into error in the rod. So absolute percentage error is computed as. So we have formula for absolute computed error, that is EA by A into 100. So EA by A is 2 pi r into ER by A is pi r square into 100 to find the absolute error value. Now again, if I substitute this, 2 into, see, pi r square cancel. So 2 into er by r into 100. So again, which is equal to 2 into er, nothing but 2 into 0.2%, okay, which is equal to 0.4%. This is the answer for your absolute percentage error in computed area of the rod. Thank you. Welcome. This is one more previous gate question, 2022 for 1 mark from photogrammetric topic. An aerial photograph is taken from a flight at a height of 3.5 kilometer above the MSL or mean sea level using a camera of focal length 152 mm. Okay. The average ground elevation is 460 meters above the mean sea level. The scale of photograph is. So we have formula for this. S is equal to always F by H. F is the focal length and H is the elevation from the ground. So here he is asking to find. He is asking to us to find the scale of the photograph. So here, if you observe carefully, we are having two heights. One is flight at a height of so and ground elevation so and so from the height. So here the formula will be F is equal to, okay, HM minus H. Okay, flying height of aircraft minus height of the elevation from the ground. So let me write the given data. Here F is flying height, that is flying height HM. Okay, let me write like this. Height above mean sea level is 3.5 kilometer, that is 3,500 meter. Next, focal length F. F is 152 mm. Okay, and average ground elevation is 460. This is H. That is 460 meters. Sorry, mm above the mean sea level. So it is 460 mm above the mean sea level. So if we substitute all this in the formula, so S is equal to F by HM minus H. So here F is 152 mm by 3,500 minus 460 into 1000. That is 1 is to 20,000 is my answer. So why I am applying the 1000? Because here F is in mm. Okay, F is in mm, and this is in meters, and 460 is also in meters. So this is mm, it is also mm. So F by H. So for F is 152 mm and HM minus H. HM is height of the flying height of aircraft, that is 3,500 minus average ground elevation of object above the mean sea level. So 3,500 kilometers into meters I am converting. Okay, so actually 3,500 kilometers now I am converting into mm, that is 3,500 meters. Okay, 3,500 meters and it is also 460 meters. Okay, not mm, 460 meters. So that is 152 by 3,500 meters minus 460 meters into 1000. So my answer is 1 is to 20,000 is the answer for this problem. Thank you. There is one more previous gate question, 2022 for 1 mark. A line between station P and Q laid on a slope of 1 in 5 was measured as 350 meter using a 50-meter tape. The tape is known to be 0.1 meter too short. The correct horizontal length in meter of the line PQ will be. So he's saying that it is slope. Let me draw a figure like this. It's slope here. Okay, the triangle is a slope here. So there is an angle theta that is 1 in 5. This height is, let me call a small h, and I am measuring on the slope. Okay, this is a measured length on the slope. So this is L. But in general, when I measured and found up to here, this is the correction. This is CS. Correction this is called hypotential elements. So the length on ground AB is 10 meters. When I measure along a slope, it will be coming up to here because there is an extra portion is there. So the distance AB, whatever is on ground, is not equal to the length of whatever is on the slope. It is coming less than the edge of this point. That is called as C. So AB is not equal to AC. So AB is equal to AC dash. So this C dash is called hypotential elements, right? So similarly, in this problem, we have some given data. H is difference in elevation between ends. L is inclined length measured. L, small l is the horizontal length. CS, correction due to sag, and correction due to slope. We have formula. Correction due to slope, we have formula L cos theta minus 1. So I have formula L cos theta minus 1. So we have slope of 1 in N, indicate that theta slope of line, okay, slope of line is 1 in 5. Nothing but theta, tan theta you take, okay, tan theta is equal to 1 by 5. If theta is equal to tan inverse of 1 by 5. Therefore theta is how much? Theta is equal to 11.31 degrees. Okay, this is my theta value. So I have substituted theta in L cos theta minus 1. Before that, I got theta value here. Now, let's substitute this. L is measured length 350 meters is given somewhere in the question. This is 3 is the meters. Okay, so 350, sorry, 350 into cos theta. That is cos 11.31 degree minus 1. Okay, so here my correction is minus 6.8 meter. This is equation 1. You take as one correction in this. So next, so normal length of the tape is 15 meters given, but there is a short length of 0.1 meter in the tape. So this is L, and I have L dash also. L dash is equal to 49.9 meters because 0.1 meters short. Okay, so L dash is 49.9 meters. Now, if you want to find the true length, okay, true length L is equal to, again you take as L. L is equal to, okay, measured length into incorrect chain length by correct chain length. So measured length is how much? 350 meters into 49.9 by 50. Okay, that is here mean length, correct length of the line is 349.3 meters. Okay, that is 349.3 meters. Now we have two corrections. So let me do the corrections first. The first correction is 349.3 minus 350. Okay, corrections. That is 349.3 minus 350. The first correction value is how much? That is minus 0.7 meter. Okay, minus 0.7 meter, and one more correction is minus 6.8 meters. So we have two corrections. One is slope, correction for slope. One is correction for incorrect chain length. You got the point? One is correction for the slope. One is correction for the incorrect chain length. Now, if you want to find the true length, you should apply net correction. So that is net correction is equal to minus of 6.8 is 0.7. So my net correction is how much? Minus 7.5 meter. So my measure length is 340, sorry, 350, 350 minus 7.5 meter. 1 second, let me calculate. 350 minus 7.5, that is 342.5 meters. Okay, so you subtract the 7.5 from the measured length, that is 350 minus 7.5. Okay, that is how much? 342.52 meters. This is my option A. Okay, right? Thank you. Problem is solved. there is one more previous gate question, 2022, for 1 mark. The question says that the bearing of survey line is north 31 degree 17 minutes west. The azimuth observed from north is in degrees. Round off to 2 decimal places. So if I take quadrant systems, north, south, east, and west. So here my quadrant is survey line is northwest direction. Let me take as O. Okay. So from north it is about 3. Sorry, that let me tell you. Okay, right. From northwest. Okay, 31 degree 70 minutes. It is in fourth quadrant. Okay, northwest in fourth quadrant. Let me convert this QB, that is quadrant bearing system, into whole circular bearing system. So 360 minus theta. 360 minus theta, whatever the angle it is. 360 minus degrees minus 31 degree 17 minutes. So I want to convert in azimuth bearing system is also called as true bearing or whole circular bearing system. 360 degrees minus 31 degrees 17 minutes is 328 degrees 43 minutes 00 seconds. This is one answer, or it is also written as 328.72 degrees. Okay, actually you can write 328.72 degrees or 328.43. Okay, 328.43 minutes also is correct. So you can, if you want to round off, you can write 328.72 or we can write as 328.43. In general, 328.43 is only the correct. If asking to round off in decimals, then you can write as 328.72. So mostly prefer for this type of options in these questions. So he's asking the fourth quadrant, you just convert into WCB, and in if you want to azimuth, subtract from 360. So 360 minus the fourth quadrant bearing system, that is 328 degree 43 minutes 00 seconds is my answer for this problem. Thank you. Problem is solved.